Okay, so this video is in preparation for the final exam, specifically questions on the final exam that have to do with Chapter 7. So here we go. So, first thing we're going to talk about, remember the product rule, right? So we have square root of 5 times square root of 13. Or the product rule of radicals implies that when we have a case like this where we have the same common index, our index here is 2 because they're the square root, we can multiply what is underneath the radical sign, which is the radicand. So we multiply the radicands here, and we end up with square root of 65. So remember the product rule for radicals. And B is we're applying the same thing here. These are both of the same index, so we can combine them in this way by multiplying what is underneath the radical, that is multiplying the radicands there. So we end up with square root of 7xy there. Now, I want to bring attention to, we talked about 4 conditions for simplifying radicals. And I want to bring attention to this particular case because it will show up on the final exam. If we have a case like this, we've got the cube root of r to the 12th. That violates the 4th rule for simplifying radicals, because we have a radicand and index they must have a greatest common factor of 1. Here they have a greatest common factor of 3. So we handle this in a couple ways. One, we can think of r to the 12th to the 3rd. What we did was convert the radical into a fractional exponent. Then we can apply the power rule there by multiplying 1/3 times 12, which is the same thing as 12 divided by 3, and we end up with r to the 4th. You can think of it in another way as r to the 4th times r to the 4th times r to the 4th. We're actually taking the cube root of this, and what this is r to the 4th cubed, right? So we take the cube root of that, and it's r to the 4th. So then looking at a very simple way that we handle when we simplify these radicals, remember we first find a perfect square factor, and 32 can be factored into 16 times 2. When we're looking for the largest perfect square factor to ensure that we simplify these the best way. So we take the square root of 16. We just take that out. We're doing the reverse of the product rule for radicals. Take the square root of 16, and we get 4 square roots of 2. So we've simplified the square root of 32 into this form right here. Square root of 300. First, we think about what would be a very large perfect square factor, and that's 100. So we take 100 times 3, we get 300. So we break that apart using the reverse of the product rule for radicals. Take the square root of 100, and we simplify the square root of 300 into its simplified form of 10 times square root of 3, or 10 square roots of 3. So we're looking about, we're going to continue on with how we handle these radicals. Remember, if we have some numbers multiplied by radicals of the same index and the same radicand, we can combine those. So this is the same thing. 3 square roots of 5 plus 7 square roots of 5 is the same thing as 3 plus 7 square roots of 5. Basically, we're using the we're using the distribution rule there. We factored out the square root of 5, sort of, what we've done there. So that becomes 10 square roots of 5. So in B, we have 2 square roots of 11 minus square root of 11 plus 3 square roots of 44. Remember, they have to be of the same index and the same radicand. These first two are. This second one we can break apart because 44 can be factored into 4 times 11. So what we do here is we take the square root of 4, move that outside. The square root of 4 is 2, so we take 2 times 3, we get 6. So now we have everything of the same index and the same radicand. So 2 square root of 11 minus square root of 11 is 1 square root of 11 plus 6 square roots of 11. We end up with 7 square roots of 11. Now, this next piece here is about rationalizing the denominator. Remember, when we rationalize the denominator, we multiply the numerator and denominator by the denominator, which is the same thing as multiplying by 1. So what we do is multiply the numerator and denominator by square root of 11. So 5 times square root of 11 is 5 square root of 11. Square root of 11 times 11 is the square root of 121, which is 11. So another way to think of this, if you take the square root of something times the same square root of that same something, you're going to end up with that something, which just makes logical sense there. Square root of 11 times square root of 11 is 11. So what we've done here is rationalize that denominator. So we'll look at the next one. We're going to multiply by the numerator and denominator by what is in the denominator because we have a radical in the denominator. So we're multiplying the numerator and denominator by square root of 5. So what we end up with is 5 square roots of 30 over 5, because square root of 5 times square root of 5 is 5. We use the product rule here for radicals. 6 times 5 is 30. The 5's cancel out. And square root of 30 is already simplified as far as it'll go. Doesn't have any perfect square factors, so we can't simplify that any further. Now we're talking about multiplying complex numbers. So what we're going to do is distribute the 6i times these two terms in this binomial. So 6i times 4, 6i times 3i. Remember, something very special happens when we multiply I times I, we get I squared. So we got 6i times 4 is 24i. 6i times 3i is 18i squared. Remember, I squared is negative 1. So we replace the I squared with negative 1. And we end up with our complex number here of negative 18 plus 24i. Or we've got to put it into standard form by putting the real part first, followed by the imaginary part. So negative 18 being the real part, 24i being the imaginary part. So we'll look at this one here. We've got the cube root of x to the 9th. So we divide, one way to think of this is divide the exponent of the variable by the index. So 9 divided by 3, we end up with x to the 3rd. That's not necessarily the mathematical way to think about it. The mathematical way to think about it is to convert the rational exponent, convert the radical to a rational exponent, which we did here because remember the denominator is the index of the radical. So then we would apply the power rule. So we end up with 9 divided by 3, which is the same thing as x to the 3rd. Just a couple ways to think about this, and you end up with the same result there. So now multiply a possible using the product rule. They give you a big hint here. Use the product rule. So remember, with the product rule, we multiply what is underneath the radical. So we're going to multiply 3 times 192 because we're multiplying the radicands, and we end up with square root of 576, sorry. Now 576, what we would think about is, are there any perfect square factors? So we'd break down 576, but actually 576 is 24 squared. So 576 simplifies to 24. Then again, notice it says use the product rule. So what we do is multiply the radicand. So we would have 14 times y, which is the same thing as 14y. And that we've simplified that. We've simplified this already. The big hint here is it tells you to use the product rule. So now we're going to simplify this one here. First thing we do is find the perfect square factor of 20, which is the same thing as 4 times 5, 4 being the perfect square factor. We take the square root of 4, we move it outside. Now we multiply by the number on the outside of the radical, 2 times 2, and because we took the square root of that factor. So we got negative 3 square root of 5 plus 4 square root of 5, and because we've multiplied the 2 times 2, and then it's negative 3 square roots of 5 plus 4 square roots of 5, same index, same radicand. We can combine those, end up with 1 square root of 5 together. Now this one asks us to rationalize the denominator, because remember, we cannot have a radical in the denominator. So what we do is we must take make the denominator rational. So what we do here is we multiply the numerator and denominator by the radical of the denominator, which is square root of 5. So we're multiplying the numerator and denominator by square root of 5. So in the numerator we're going to apply the power rule. So we multiply what is underneath the radicand. 2 times 5 gets us 10. Square root of 5 times square root of 5 is square root of 25, which simplifies down to square roots of 10 over 5. And then 10 can't be broken down any further because it doesn't have any perfect square factors. Remember, it says to rationalize the denominator, and that's what it means by rationalizing the denominator. So then this one says to find the product. So what we're going to do here is multiply. We're going to distribute that 6i. And we got to remember that I squared equals negative 1. So we distribute the 6i. So 6i times 2i. And minus 6i times 5 is negative 6i times 5. We're distributing. We've got 12i squared minus 30i. Remember, I squared equals negative 1, so we make the substitution there. And there's our final answer here, with having the real part and the imaginary part. Remember that I squared equals negative 1. It's very essential that you replace the I squared with negative 1 there to complete the problem.